Greetings everyone. Time for a little update. The transverter is completed. I've managed to put everything in an enclosure, and here's how I built it. It's like I had planned, built on a carrier board, except I decided to use a PCB instead of an aluminum plate. And the reason for that decision is this sits pretty low in the enclosure in the lower groove, and I wanted to gain as much space as possible before hitting some metal. So I decided to use a PCB instead, which along with some spacers here raises the lower surface from the metal surface here, and we know that all the electronics are on the lower side of the PCBs. So this buys me more space as opposed to having used a metal plate here. And as far as the grounding goes, everything is interconnected, so there won't be any issue. Everything is self-supported, and when everything is closed, it's all sealed in a metallic enclosure, aluminum in this case. So yes, I did put everything on a single carrier board, as you can see. The transverter board is here, the LO tripler board is here, and the LO or synthesizer board is here. So this board takes 10 megahertz in from outside. It produces 3.408 gigahertz signal. That's sent into a tripler which produced 10.224 gigahertz signal. That LO signal goes into the mixer, and then the mixer picks up both branches, the transmit branch and the receive branch. It's the same board and same configuration as what I used on my previous portable 10 gig system, which I detailed in several videos, and the series of videos I will provide a reference in the description below. So yes, it's the same design, so that's why I'm not detailing the functionality of this system, and pipe cap filters, how to install them and everything else. I discussed this in many videos in my previous system. But the exercise here was to put everything into an enclosure as small as possible, and it works. It barely works. As far as the clearance, if you look at when I insert the system here versus the tuning screws, right here on top, the copper screws, it fits with about not even 2 millimeters of clearance, maybe 1.5 millimeter of clearance, which is perfect. It's all fine. And yes, I use some short pieces of coax to reach the 144 megahertz input here and the 10 megahertz input here. Well, the 144 megahertz is actually both input and output, right? And on the 10 gig side, all I needed was to drill 2 holes like this to let the SMA connectors through the plate. So that's it. For spacers, I used Bakelite washers, stacked 3 of them. I have a ton of these, so I use these, and I use metric M3 screws. And one thing I want to mention that I did this time that is different from the last time, because on my portable system these are 3 separate boxes: synthesizer, tripler, transverter. I decided on this design to make things more compact, to link the 2 boards. The 2 tracks line up and are soldered together. So I made sure I filed off the edges so that the traces are as close as possible one with the other, and soldered the middle track, of course, and used some stiffening pins to give a lot of strength in the joint. Otherwise, just soldering would have been a bit weak, in my opinion. And then put a lot of solder to bridge the ground planes, of course. So what did it do? Saved space and saved losses, because this saved me 2 female connectors plus either an adapter, male-male, or a cable. So saved some gain here by doing so. Now, a few additional comments. I'm still missing a few dBs, actually around 6 dB of gain on the transmit path. I get plus 9 dBm of output for 1 dB saturation. I need around 15 dBm. So I'm missing 6 dB, and I'm looking into purchasing a small gain block that will get me to around plus 15. It's not going to be a cheap solution, but the Chinese make a little box that sells for around $70. This is one possibility. I'll keep on looking around if I can build something for cheaper, but things are very, very small at those frequencies, and it's difficult to design cheap PCBs for those frequencies with very narrow tracks and very thin PCB material. And for $70, when you look at all the cost involved, it's all tested working, it's probably not worth trying to build something. Anyway, something to look into. I will also need to build the switching attenuator for the IF for the 144 megahertz. You remember that in a receive situation, whatever comes from the transverter goes to the IF radio at 144 megahertz. We don't need any attenuator in line, but when we transmit say half a watt. We don't want half a watt into this thing. We need to attenuate by at least 30 dB. So it requires a switchable attenuator that works at 144 megahertz. So a little box I will have to build. I built one on the previous system. I'll see if I use the same configuration or do something else. To be seen. I've also received my controller board. It's a different design from the previous system. This time it uses a Raspberry Pi Pico for many reasons, one of them being communication between this board and the one in the shack. But this board also has a 10 megahertz OCXO, an ovenized oscillator, to feed my transverter with a stable 10 megahertz signal. And yeah, it's all adapted for this system. It can control a fan, it has temperature sensors, and so on and so forth. So we'll have a look at this in a future video. Don't worry. It's a much more complex design than the simple transverter I had on the portable system. So that's the update for now. It's definitely advancing, but there's still a lot to do to have a complete system. But there are a few more months available. So stay tuned. 7-3.